Can I have a brave soul to tell me which is the longest side? Which is the longest side? Sam.
Or longest side is CB.
Is CB. So that means your biggest angle would be A. Yep. Your longest side is CB, and your longest side is always across from your biggest angle. So that would mean angle A is my biggest angle. Is bigger than, what's my next biggest angle? What is my next biggest angle? Tori. Angle B. And that's probably because A to C is our next longest side, so it would be angle B. And who wants to take a complete shot in the dark? What is the smallest angle? Yeah, it'd be angle C. Hopefully you know why, and not just process elimination, that you're just like, well, A and B is already taken care of. All right, questions on that? Questions on the homework? Isabel.
Can you explain how to do number 14 on that? What
Okay, number 14. All right, so the first thing you'd have to do is get all your angles, right? So when I start with, okay, this is 50, this is 50, so that measure right there has to be 80 degrees. And then we went ahead, and what other stuff did we give us here? All right, so that's 80, and we said, are these markings here on yours? Okay, so these are congruent. So that means these two angles are congruent. Let me highlight what I'm saying. So these two have to be congruent because these two sides were congruent. So if you do those math, those have to be 55 and 55, which makes this 55 and makes this also 55.
Okay.
The other way you could have looked at it too is this little tick mark here meant that, let's go about this a different way. Another way you could have done it is this side and that side are congruent. So this has to be an isosceles triangle, so both of these need to be congruent. So this needs to be congruent with that. So once again, they both would have to be 55, and you could do the same thing up there. However you get there, you need to get to those were all 55 and everything else. Was that enough, or did you already know that and you want to go further?
No,
That's good?
Yeah.
Okay. Any questions on this one, just real quick? Yes, Hamza.
So on this one. Do we know that VB is the longest one because of the 80 degree angle or because of the 270 degree angles on it, which make 140?
VB?
Yeah.
Oh, we treat each individual triangle. So we're going to go with each individual triangle. So if you look at this triangle here, I'm looking at that triangle there. I came up with that VB is bigger than VA and AB.
Yeah.
And then I went to the next triangle. And it says that VA is the biggest there. Well, VA is smaller than VB, so VA is not an option. All right? And then we do the same thing down here, and we came up with the AB is the largest in this triangle down here. Well, AB is smaller than VB, so VB has to be the biggest one.
Is it okay? I just did it this way. I just found like which angle was the largest and then which side opposite to it. What?
It'll work most of the time, but not every time.
Okay.
All right.
So we have to do it that way.
Yes.
Okay.
Mm-hmm. All right. Yes.
For number 6, how did you get the bar?
For number 6. Oh, we're just coming up with our smallest and lowest?
Yeah.
Okay. So we have so whenever we're doing sides like this, let's go to maybe a different problem. Let's say I am looking for the value of x if I have 6, 9, and what are my possible x values? To get my lower value, we do 6 minus 9 absolute value. is less than x is less than 6 plus 9. So the first one is just minus. The second one is just plus the two sides that we know. Okay? So if I do the same thing here, if I do one side minus the other side, we do the absolute value, either we do k minus k plus 5, or we do k, how do I put this? So that's one side, right? And I'm subtracting the other side from it. So it's k plus 5 minus k. Well, k minus k is just 0. So it'd be 0 plus 5, which is just 5. If you went the other way with it and you said, well, I can also do k minus k plus 5. That should work, right, as long as I take the absolute value of it. That would equal the absolute value of k minus 5. Those turn to 0, and I'm just left with the negative 5, but absolute value would equal a positive 5 as well. Does that clarify? Okay, good. Other questions? Hamza.
On number 15.
Mm-hmm.
So like for the line E, right,
Mm-hmm.
there's two angles opposite it, right? So like there's a 61 degree angle,
Mm-hmm.
there's a 59 degree angle. But doesn't that mean that you will have two different lengths?
Nope.
Two different angles opposite it.
Just two different angles opposite it.
Oh, but if like one angle is like slightly bigger than the other, doesn't mean that line has to be also bigger.
How does it make it bigger? Look at this drawing here. This angle up here is definitely smaller than this angle, but does that change the size of this line?
No, because it's farther away.
Because it's farther away. That's why you have to treat it as two triangles. All right, don't treat it as... So this is one of those, remember how you said, can I just find the biggest angle and whatever side opposite is the longest line? It doesn't work here. In fact, on this problem, you have to separate it into two triangles, and that's why I put it down there. I said you have to first look at that top triangle, and then you get C is bigger than D is bigger than E, and then you have to look at that bottom triangle, which comes up with E is bigger than B is bigger than A. But E was the smallest here, and it's the biggest here, so you can just attach those two statements saying that C is bigger than D is bigger than E, which is bigger than B, which is bigger than A.
Yeah, okay.
So that's where your whole biggest angles, biggest side kind of breaks down, because if you're using that logic, it would seem like it'd have to change sides
Yeah.
or sizes, but it can't because it's a fixed size. Other questions? Yeah, man.
Number 16.
Yeah. How did I come up with that?
Because you had angle 3 is greater than angle 1, which is greater than angle 2.
Uh-huh.
But I don't understand how you got that.
Oh, you think it should be measure of angle 2 is bigger than measure of angle 1? Okay, let's look at that. All right, let's look at the values here. So if this is 90, this is congruent, that's congruent. We agree this is 45 degrees, right? All right, and that's 45 degrees. Well, this is 90 degrees. So there's 90 degrees we can share between 2 and 3. Either we split it right down the middle and they're both 45, or one's bigger than 45 and one's smaller. So one could be like 46 and one could be 44 degrees. So then we look at the fact that angle 3 has to be bigger than 98, right? And angle 3 has to be bigger than 2, because 98 is bigger than 97. You agree with that, right? So this statement must be true. Well, in order for 3 to be bigger than 2, let's look at the first part that can make it bigger. 3 could be 46 degrees, which would make 2 44 degrees. Or 3 could be 47 degrees, and 2 could be 43 degrees. The only thing they can't be is both 45. 3 always has to be bigger than 45, and 2 always has to be less than 45, because either they're equal or one's bigger and smaller than 45. So that means 2 has to be smaller than 45, which means 2 has to be smaller than 1, which means that is the correct order. Other questions? Hamza.
Can you go over how do you do numbers 17?
So 17, you have to look at the 2 triangles. Without spending a lot of time, we just have to use a little bit of logic on this one. That's what makes this one a little harder. So we're going to look at this triangle here led me to that fact. And then I took out the big triangle here and put it right there, which led to this fact. So we have measure of angle 2 is bigger than measure of angle y is bigger than measure of angle 1. And down here we have measure of angle x is bigger than measure of angle x, zy is bigger than measure of angle y. Well, the odd duck out is measure angle 2. Because if that wasn't there, if we didn't have measure of angle 2, we could go ahead and say, well, measure of angle x is bigger than measure of angle zy is bigger than measure of angle y, which is bigger than measure of angle 1. And we'd be done. The problem is we have this angle 2, and I think the easiest way to do this is just kind of use a little bit of logic. We'll have some more tools at our hands later on. But if we look at this angle here, they both have to reach 15, right? Well, the only way that this could also have a hypotenuse of 15 is to have a bigger angle. To go even further, that has to be bigger. The closer you get to this side, it has to be a bigger angle. And the further away we get, the smaller that angle is going to be. So it's just kind of logic on this one that 2 has to be bigger than 1, using that kind of logic. You don't have to do anything like that on the test. It just makes for you have to like think what it means to be an angle and create that stuff. All right, we have to get into today's lesson so we can get done. All right, today we're talking about the hinge theorem. The hinge theorem is kind of just like those pictures that are right there, but I'm going to take out my own rulers really quick. The hinge theorem is determined on the fact that I know 2 sides of a triangle. I know 2 sides of the triangle, and they are stuck together on a hinge. Well, these 2 sides are fixed, right? I can't change these ruler sides. If I have a small angle, it would be a small side over here, right? And the more I open this up, the bigger that third side needs to be to accommodate that new angle side. So if I went way up here, that's going to be a long side compared to that. Can we all kind of picture that with this? That's all the hinge theorem is. It is that if you have fixed sides, the bigger you're open, the bigger that third side is. The smaller that angle, the smaller that third side is. So if I asked you which side is bigger than which, and I gave you this one and that one, you'd say the second one would have a bigger third side, right? Just by looking at it. Well, that's what we're doing. That's exactly what this hinge theorem is saying. It is saying if 2 sides of one triangle are congruent to 2 sides of another triangle. So that's my 2 rulers. That's how we compare the 2 angles to each other. They must have congruent sides. Once again, if 2 sides of one triangle are congruent to 2 sides of another triangle. So this part is pretty important to have to check for. Check to make sure you have that congruency. And the included angle, which is going to be known as our hinge angle, of the first is larger than the included angle, which is the hinge angle of our other one. Then the third side of the first is longer than the third side of the second. So what you're actually looking for, you're looking to make sure 2 sides are congruent, and you need to be talking about that angle that's between the 2 sides. It's kind of like thinking about side, angle, side. I need to know 2 sides, and I need to be talking about that angle in between it. All right, so you need to know side, an angle, and a side, and that angle between them is your hinge angle. I can't stress it enough. You might put some notes in there, but you have to have two congruent sides to have a hinge angle. And the only hinge angle is the one between the two sides. All right, we have two congruent pairs of sides in both of these. We have Vx is congruent to RT. We also have VW is congruent to RS. And we're talking about the angle between those two congruent sides. So that makes them a hinge angle. Well, angle V, the measure of angle V is bigger than the measure of angle R. So based upon that hinge angle theorem, the side opposite our hinge, which would be WX, it shouldn't have a line of it, but will be bigger than ST. And that's the hinge angle theorem. Based upon you knowing two congruent sides. Yeah?
Why doesn't it have a line above WX? Why shouldn't it?
You can. It shouldn't because it's length.
Oh.
But it doesn't really matter with the greater than or less than symbols. So there really isn't anything wrong with that. And you'll see in the answer key, I'll kind of switch between the two. But more correctly is the length, because that says the length of WX is bigger than the length of ST. We're talking specifically about length. That if you just say WX is saying the line is bigger than another line, you're like, length or width or what are we talking about? But we're not going to nitpick on that stuff. So if you have a line above that, awesome. If you don't, awesome. All right, questions on that? The converse just goes the other direction. The converse goes the opposite direction, but we still have to make sure we have a hinge angle. To have a hinge angle, you have to know two sides are congruent on both triangles. So if we look down here, we know AC is congruent to DF, and we know CB is congruent to FE. So that makes our angle C a hinge angle, and it makes F a hinge angle. Now, either we know the hinge angle size, or we know the side opposite it. If you don't know either one of those, you don't have a hinge angle theorem. All right, it falls apart. Once again, to use a hinge angle theorem, you have to have two congruent sides, two pairs of congruent sides, and you need to be talking about that angle between the sides. It meets all those requirements. So this is a hinge angle theorem. Well, the converse just says, well, if AB is bigger than DE, the sides opposite our hinges, then our hinge angles will be different sized as well. AB is bigger than DE, so that means the measure of angle C is going to be bigger than the measure of angle F, our hinge angle. So that's what this whole statement's going to say to you. That is our converse. Questions on that? That is it. That's all we're learning today. Now we're just going to go to practice it a few times, and you'll be cut loose. All right, real quick, let's go through. Let's go through these together. We'll go through some of these together, and then I'm going to put you on your own to do those. All right, our first one says AB is bigger than DE. Or something to DE, sorry. All right, so in order for it to be the hinge angle theorem, you have to have two pairs of congruent sides. Here we have CA and DF, and we also have CB and FE. We have two pairs of congruent sides. Now we have to ask ourselves, are we talking about the angle between the sides? 105 and 110, yep, those are the included angles. So those are hinge angles. So those are, in fact, our hinge angles. And our hinge angles right now are 110 and 105. Well, since it's a hinge angle, the side opposite 110 must be bigger than the side opposite 105. Well, the side opposite 110 is DE. So DE needs to be the bigger of the two sides. So we should have AB is less than DE. Our next one, I have to determine if I can use the hinge angle theorem. I have to check for two pairs of congruent sides. Well, we have FH and LN, and we also have HG is congruent to NM. Check. Now we have to make sure we're talking about either the included angle or the side opposite that included angle. In this case, we're talking about the included angle because we have 117 right between the two sides, and we have 117 here. Since they're the exact same, that must mean that third side must be also the exact same. So that's going to be equal. In fact, we could prove they're congruent because we have side, angle, side all being the same. All right, C. I'm going to check to see if I can use the hinge angle theorem. I need two pairs of congruent sides. I have one pair of congruent sides, and I have do we have another pair of congruent sides? No. Eventually we'll be able to prove we have two congruent sides, but we don't know much about right triangles in this class. We haven't talked about right triangles. We haven't talked about SOHCAHTOA. We haven't talked about any of that. So you don't actually know another side. So for right now, we can't use the hinge theorem. I'm not saying that we can't determine it, but we can't use the hinge theorem. That's the most important part. If you'd say measure of angle 2 is bigger than measure of angle 1, you are correct. But we can't use the hinge angle theorem to say that. All right? So right now, we can't use the hinge angle theorem unless it checks both those boxes. All right, questions on that? Okay, then you guys are going to be responsible for doing these three in just a second. We're going to come back here and we're going to do this one together, and then you're going to be responsible for the other three there, okay? So let's go through this one together. So we're supposed to complete the following statement with less than, greater than, or equal to. So they're going to give you like two sides or two angles or something like that. So they tell you to look at AC and EG. So either on your sheet or just in your head, picture what AC and EG are. And then before you mark it up too much, you may want to just picture the triangle that creates those segments. And then you have to ask yourself, does the hinge theorem apply? Do I have two congruent pairs of sides? Well, with this ACD, we have CD is congruent to DE, that's one pair. And we also have AD is congruent to DG, that is my other pair. I can use the hinge angle theorem as long as I'm talking about the angle between them. Well, we are. Angle D is between both of them, ADC. And EDG. So those angles are between those two known sides.
Keep studying.
And both those angles are the exact same. So if those angles are the exact same in the hinge theorem, neither is bigger than the other. So this is just going to be equal to. All right, so right now I want you to finish those next three, and then I want you to do these three as well. If you'd like to, you can try this one. We'll get to that in just a second if you have too much time. But while you guys are working, I'm also going to walk around and I'm going to check your homeworks, okay? Since I'm on this sheet, let's just go with this one. So I need to first check to see if the hinge theorem is going to work on D. So I'm going to look at, we have tick marks that say those are congruent. And don't forget about shared sides being congruent. So there are two pairs of congruent sides. And these 1 and 2s are smack dab between those two things. And the side opposite is 6. Since our side opposites are equal, that means those angles are also equal. So measure of angle 1 should equal angle 2. Our next one, well, MT is congruent to TL. They gave us that. We should also know that TS is congruent to TS because it's a shared side. And this is these 95 and 98 are those angles between those congruent sides. So we can use the hinge theorem to look at the side opposite. Well, 98 is bigger than 95, so SL must be bigger than MS, so we should have MS is less than LS. Our final one, we do have two pairs of congruent sides. We got these, and we have this one, and the angle 1 and 2 are smack dab in between. So we have side angle side. So that means we can actually use our hinge theorem. They gave us the sides, 9 and 8. Since 9 is bigger than 8, 1 must be bigger than angle 2. So we should have bigger. All right, questions on any one of those? All right, and let's go back to this one. All right, they said we need to compare AB to FG. So if I erase what I just did here, and we're talking about AB and FG, so what I'm really looking at is this triangle here and this triangle here. I got to first make sure they have two pairs of congruent sides. Well, they have that 16, 16, 16, and 16, so they do have two pairs of congruent sides. So we're looking at the angle between them is 116 and 110, so we can use the hinge theorem. 116 is bigger than 110, so the side opposite 116 is FG must be bigger than AB. So we should have AB is less than FG. All right, two more to go. Two más. Erased. All right, this one actually gives us values. It says BE equals 12, so let's write that down. It also says that EG equals 8. So I must be dealing with this triangle and this triangle. All right, so we have to have two pairs of congruent sides. We can look at those 16 and 16. And we have that shared side, so I do have two pairs of congruent sides. So this angle right here, this 32 degrees, is going to be the hinge for that 8. And this angle here is going to be the hinge for that 12. Well, 12 is bigger than 8. So this angle right here, this BDE, must be the bigger of the two. So we find that BDE and make sure it's bigger than the other one. All right, final one. We have EG equals 8 and CF equals 8. Well, we already had EG's 8. CF is 8. We're talking about this triangle and this triangle based upon those sides that they gave us. We have 16 is congruent to 16. 14 is congruent to 14. So these must be our hinge angles. 8 is congruent to 8, so our hinge angles must be congruent. That's an awkward equal sign. That's a better equal sign. All right, questions on those? Okay, so let's go down to these. These can be sometimes more challenging. These are just going to give you facts, and you have to come up what the statement is on the other side. So let's look at that first one. The first one says that AB is equal to BC. So you kind of have to picture this in your head. On here, I'm going to draw it. All right, AB is equal to BC. It also says measure of angle 1 is bigger than angle 2. So if I highlight those angles, we're talking about this angle here and this angle here. So we must be talking about these two triangles. Well, we have AB is congruent to BC. We also have this BA is congruent to BE. I'm sorry, BE is congruent to BE. So I have two pairs of congruent sides. So I'm talking about angle 2 and angle 1. Well, it says that angle 1 is bigger than angle 2. So the side opposite angle 1 must be bigger than the side opposite angle 2. Well, the side opposite angle 1 is AE. So there should be some kind of statement that says like AE is bigger than EC or EC is less than AE. So we go down to D, and at D says AE is bigger than EC. So all we're going to do is we're just going to line that up and say, well, that's the answer to that one. All right, you guys are in charge of doing those other 3, and as soon as you get done, you can. All right, the next one says that EA or AE is bigger than EC. So let's highlight E. Let us highlight AE. AE is right here. And they also talk about EC. And then they say AD is equal to CD. Real quick. AD is congruent to CD. So those two things are congruent. So we do have a side. We have our hinge angles are going to be 7 and 8. Guys, I thought me standing here was going to suffice. It did not. So we do have a side. That's our hinge angle. And that's the other side that's congruent. So our sides opposite would be these. And it does say that AE is bigger than EC. So the side opposite would be 7 is bigger than 8. So our next one would have been A. Hemza.
Why aren't the hinge angles 4 and 6?
Because those aren't the fixed sides. It says directly that AE is bigger than EC. The hinge angles always has to be between the two congruent sides. That was a requirement to be a hinge angle. All right, really quick. It says measure of angle 9 is less than measure of angle 10. So let's highlight 9 and 10. Angle 9 is here. Angle 10 is here. Then it also says that BE is equal to ED. So that is this is equal to that. We also have AE is congruent to AE. It says that 9 is less than 10. These are definitely hinged because they're stuck between the two congruent one. And since 9 is less than 10, the one across from 9 is AB. So AB must be less than AD. In this direction, they said AD is bigger. And C actually works. We just don't have time, but it actually works. And that one is good. All right, guys, have a wonderful day.